So how to subtract one vector from the other? That's vector subtraction. Suppose there is one vector, let us say as we took in the previous two videos, and it'll be like this: 12 Newton force and towards the eastern direction, and another force which is also happening to be in the same direction, 5 Newton force in the same direction, 5 Newton in the same eastern direction. And the sum of it means we'll just bring the tail on the head of this, and we will draw a big line from this tail to that head to find the effect. But suppose this is our p vector and this is our q vector, and you need to find p minus q. All we know is if you bring this here, you will be able to add. But you know the other thing, p vector, what we essentially need to find is the difference in vector. The difference vector is p vector minus q vector. P vector minus q vector can be written as p vector plus of minus q vector. That means you are essentially adding two vectors, but adding the negative effect of the second vector. How is that? This is p vector, this is q vector. If you want to change the vector, because vector has got both direction and magnitude, if you reverse the direction, that becomes the negative of that vector. So let us reverse the direction. Now 180-degree rotation I have given. Now what is this? If this is q vector, this is actually, the length is same but the direction is opposite. This is actually q minus q vector. Now this is p vector, this is still p vector. Now to find the effect, again this is p vector, then plus of minus q vector. How do you do that? So again, now add p vector with minus q vector by bringing the tail of this onto the head of that, because this is the tail and you're bringing the tail onto the head of this, and you keep the vector like this. Now the resultant vector is this, where to where? From here to here. This vector is equal to p vector plus of minus q vector. So let us write, this whole thing is a p vector, and then this thing is minus of q vector, and this one is p vector plus of minus q vector, or you can simply say that p vector minus q vector. That is the difference between the vector. That's how one should do subtraction. In the last video we had seen like parallelogram law of vectors, where we found the effect of two vectors. Suppose let's take this example, it's a very important one. We are going to apply the same. So if this is p vector and this is q vector, and the sum of these two vectors, like if the angle between these two vectors is theta, if this is p vector, this is q vector, and this is theta, then r vector can be found like this. So how do we find the r vector? Just by keeping it over here and by drawing a resultant vector from here to here. This is what the r vector. We know that this r vector equal to p vector, and this is q vector, p vector plus q vector. The magnitude of r, as we had calculated, the magnitude of r equal to, simply it is called r, that is equal to root over p square. That means magnitude of p whole square. We will be writing like this: modulus of p whole square plus modulus of q whole square plus 2 times p dot q. That's how we bring in the dot product. So this is nothing but p square plus q square plus 2 into modulus of p modulus of q into cos theta. That is the definition of the dot product. A dot b vector equal to modulus A modulus b cos theta. Why did we do a dot b as this way? We will explain in a separate video. AB cos theta. So this is equal to root over p square plus q square plus 2 modulus of p is p, modulus of q is q into cos theta. This is r vector, which is a vector plus b vector. Okay, what if you want to find p vector minus q vector? Let's copy this and paste it over here. Okay, we'll do another diagram. Suppose this is our p vector and this is our q vector. So in order to find p vector plus q vector, you actually brought the tail of this and placed it here and you found this. But here you want to find out p vector minus q vector. What you need to do is just reverse the direction of this vector. This is our q vector. So just give 180-degree rotation. Now because you have changed the angle 180-degree, like this is now what? Minus q vector. So the dimensions of the parallelogram will not change, only the direction is reversed. If this was p vector, this was q vector, this is minus q vector, but length of this line and length of this line will be the same. Now you bring this minus q vector and in fact to the head of this vector and find the magnitude of this. So it will be like, so I'll just do the other thing. So I'm going to copy this and do it there and place it here. Place the tail onto this. Now you see this is p vector, this is minus q vector. So you are adding minus q vector with p vector. So it is minus q vector. If the angle between p vector and q vector is theta, then this angle is going to be 180 minus theta. Then length of this line from here to here is the resultant. The length of this line is the resultant. This resultant vector is actually r vector equal to p vector minus q vector. Again, just form a right angle triangle using this. See what this angle is going to be. So this is p vector. Let's extend the direction of the p vector. This is it. And this line is parallel. Sorry, this. See, if this line and this line had theta, this angle is also going to be theta. But this angle is again theta. Then this angle is going to be 190 minus theta. Let us now draw this side which is 90 minus theta. Let us, and this length, and if this is theta, this is 90 minus theta. In this right triangle, if the length of this line is q, the opposite side is q sine 90 minus theta, and this adjacent side is q cos 90 minus theta. And this is a right angle triangle, and this side is p, this whole length is p, and this is q sine 90 minus theta is q cos theta, q cos 90 minus theta is q sine theta. Now this is q sine theta, so this is q sine theta, this whole length is p, and this is q cos theta, because this is q cos theta means equivalent length q cos theta. So this resultant vector has got a length of hypotenuse side of this right triangle. So this right triangle, and this length is total length p minus q cos theta and the opposite side is q sine theta. Q sine theta. So the modulus of that r vector. So the process here we are doing is this: r vector is p vector plus of minus q vector. In other words, it is p vector minus q vector. The modulus of that r vector, or simply r, equal to square root of opposite side plus opposite side square plus adjacent side square. So that is q sine theta whole square plus p minus q cos theta whole square, that is equal to root over q square sine square theta plus a minus b whole square, that is a square plus b square minus 2pq cos theta. Then resultant of the difference between two vectors is equal to square root of p square and q square sine square theta plus q square cos square theta. If you take q square out, sine square theta plus cos square theta is 1. So it is q square minus 2pq cos theta. So if p is one vector and p is one vector, q is another vector, angle between them is theta. So r vector as p vector plus q vector is equal to, the magnitude of r is equal to root over p square plus q square plus 2pq cos theta. And when the difference between two vectors, the resultant of the difference, right, p vector minus q vector is having a magnitude is equal to root over r of the difference, r of the sum. Resultant of the sum, resultant of the difference is p square plus q square minus 2pq cos theta.